Is that on? Oh, there we go. Hi, everyone. I teach my students how to make things. They come to the IOD program to learn how to work with clay, carve wood, set stones, and weld steel. What most of them don't realize is I'm going to make them spend a large period of time sitting in front of a computer, clicking away, learning how to measure angles, extrude lines, build solids, and ultimately 3D print their designs. I have to apologize, I think I made too many slides. My name is Joshua DeMonte, Professor of Interdisciplinary Object Design, and my talk is called Analog and Digital. Let's all make something together. The Object Lab over in the College of Fine Arts is a state-of-the-art lab equipped with a family of technologies known as digital fabrication. These technologies can create tangible objects from 3D computer data. We can actually print in 3D. I want to talk to you about how you go about digitally fabricating something. What this means for us, both as a university and as a community. Let's start with process. That slide is in the right place. So let's start with, okay. There are a few phases that you have to go through when you intend to digitally fabricate or 3D print something. I like to start with a concept or an idea, thinking about what this object is going to do, how it's going to work, and most importantly, what it's going to be made from. The next step is the long one. You need to develop your object in CAD software. To 3D print or digitally fabricate something, you need to model it first. There's a variety of software packages out there, ranging from very intuitive tactile interfaces to the one we use here at Towson called Rhinoceros, which is numbers and lines. After you model your object, it is time to actually digitally fabricate. So let's talk about what that really means. The 3D model you have created in your software gets sliced in a program that is connected to the printer. Usually hundreds of slices. Here I've done 40 just to speed things up a little bit. And those slices are sent to the fabrication system, which then deposits each layer down on top of one another in some sort of media. There are three primary systems, I'm going to refer to the words I wrote down. All right. Okay, so each different type of printer produces a different type of part, either with different visual qualities or physical qualities. There are three primary variations on these systems. This one here is kind of an illustration of what I would call deposition. Some sort of nozzle moves around in a space, depositing down some sort of molten media, usually a plastic, but not necessarily. Next, this system is pretty cool. It's a sintering style 3D printer. So a laser traces through some sort of powdered media. It could be metal, it could be ceramic or glass or plastic. Wherever the laser strikes the powder, it starts to sinter them together, creating a solid object. And lastly, there's an adhesion method, very similar to the sintering, but instead of using a laser, you're depositing glue into a powder, slowly building up layer by layer a three-dimensional form. So after you've 3D printed something, you have a tangible object. And as I was just illustrating, each process yields a different result. So some processes create objects in full color. Some processes create objects that are incredibly strong or very flexible. Over over in the Object Lab, we have a variety of these technologies. The first is, let's take a look. I'm going to move forward through some of these slides. All right, so the Object Lab is home to 4 3D printing systems. The first one's called a Z-Corp 3D printer. It's a pretty interesting system. It's primarily used for prototyping. It's very fast, and what's very neat about it is it can print full color parts. So we can print photographs or interesting color details right onto the surface of models that we've assigned in the computer. Next up is our SolidScape system. It prints an incredibly high resolution. It's designed for casting objects in metal. So this printer only prints in wax. Those wax models are burnt out and then cast in precious metal. This is our object printer. It can print a variety of resins, ranging from rigid to flexible, transparent to opaque. All right, and lastly is our MakerBot. This is a really interesting system. If you take a look at it up on the screen, it's made out of balsa wood and all the wires are sticking out of the side. When it runs, it kind of vibrates across the table a little bit, it beeps and it whirs. It costs roughly $1,000. For 3D printing systems, that's incredibly cheap. This system in itself has spurned a home 3D printing revolution. As of March last year, 3,500 of these printers have been sold by MakerBot Industries. MakerBot Industries also built a website called Thingiverse, where you can design your own models, and you can upload them to their website. Other people can download them and modify them. Then they'll re-upload them or print them out. It has engaged the whole community, and though this printer isn't necessarily super high-tech, it is talking about something that's moving in our direction, which is tangible objects starting to be treated like MP3s were, what, 5 years ago, 10 years ago? It's being moved around, uploaded, downloaded via the World Wide Web. All right, so a few other neat things we do. We also have 2 subtractive systems. So where 3D printers build material upwards, subtractive systems take material away. So we have a laser cutter that cuts out flat media in a variety, wood, plastic, paper, and fabric. And we also have a CNC mill, which can carve away large chunks of media in one shot. The interesting thing about these machines is that they are very restricted in what you can do, so we always have to plan ahead, but they are much more versatile in the media that you can put into them. Where a 3D printer is restricted to the one type of media that printer can print, we can stick a variety in these. Alright, so these technologies are a real fantastic resource for our students, but we don't really want to stop at the boundaries of the university. We see the Object Lab as a center point of a 360-degree conversation on how these technologies can benefit the Baltimore community. We invite local businesses, that is my cue, push the button. We want you to come work with us. We want you to come and use the lab, learn how to strengthen yourself with these technologies. We want entrepreneurs to understand how they can streamline their design process by utilizing digital fabrication. These technologies have reduced the cost of the design process and have also brought the possibility of making tangible objects to those who don't have the traditional hand facilities. We want to cross disciplines and work with our colleagues in other colleges and local schools. We want to know what the other facets of industry can do, and we really want to be a part of it. Other institutions, there's local schools. I cannot click and talk at the same time. Other institutions like CCBC have established labs of their own, and though I'm a big fan of a little friendly competition, I would very much rather collaborate. Let's work together and, of course, strengthen each other in the process. The technologies put the power of next-generation manufacturing in the hands of anybody with a computer. Why don't we make Baltimore the home of these new technologies and lead the way for a new kind of manufacturing?